Let us welcome to the another video here on electric drive. In this video we will discuss the four quadrant operation. When we say four quadrant, usually that mean like quadrant can be segregated like this, defined like this, with the y-axis as omega, which is in radian per second, and the x-axis is in torque, right? So y-axis is in speed and x-axis is the torque. So here the speed is positive and in the lower the speed is negative. Similarly, the torque is positive in the positive direction and here it is negative. To make it understand what we do, we will take some example of a vehicle, usually in the books there are two examples. One is that lift of Hoist load. Another is we can learn the same thing by using driving a vehicle in the uphill and then downhill. Let us say the vehicle look like this, right? And this is the front end of the vehicle, right? And this is the front end. Now we need to drive it in the forward direction, and then there is a downhill where we need to drive it in the downward direction. Again in the forward direction, but thing is that this is a downhill, right? So that's a difference here. So here is the downward direction. So now since we are driving in the forward direction, so we will say that here the speed is positive. So we will say the speed is positive. So this is all in this is the first quadrant, this one is the second, here it is third, and this one is the fourth. So now in this particular case, so when you are driving it upward, you are taking a car and you are driving the car upward, obviously you will try to rotate this wheel in the clockwise direction, and that means you are driving it in the forward direction. Also you are giving a torque, maybe a gear 1 or gear 2 you are giving, and you are trying to drive in the upward direction. So where here the speed is positive, at the same time this time here torque is positive. You are giving a positive torque so that you are able to drive it in the forward direction. Now when you are going downhill, you are trying to this is okay. The two option is that you can turn off the engine and this car will go downward. But there is a problem that if there is another vehicle over here, you don't have an option just like to slide down and go in the front direction because you are going to hit him. Suppose you don't have the pedal brake or something. So what will happen? You are going to hit this another car. So if suppose you don't have the brake or something, so what you are going to do? You have also one option is a reverse gear. So you can put the car in the reverse gear. That means you are trying to give a torque in the anti-clockwise direction, in opposite direction, and try to give a force in the upward direction, but your motion is in the downward direction. That means you are going in the forward direction, but since you cannot drive in the forward direction, you are going to hit the car. You cannot also turn off the engine because it will slide down. If you try to give a reverse gear and try to slowly give some power, some torque in the reverse direction, so you can able to maintain some constant speed over here, and the direction will be in the forward direction, but your torque is in opposite direction. So this, if this will come under the quadrant number 1, this will come under the quadrant number 2. That means here the speed is positive, here the speed is positive, here the speed is positive in quadrant number 1 and 2. But in quadrant number 1 you are going uphill, in quadrant number 2 you are going downhill. So here torque is negative. So here you can say it is forward motoring. And here you can write down this is forward braking. So your motion is in forward direction but you are giving a brake. So I'm telling that maybe you have a reverse gear, you're trying to give a reverse gear, or you will try to have a brake. And since you are talking about electric drive and you don't have any mechanical brakes, this type of thing, by using the leg or a hand brake you are trying to put a brake, not there. So you need to find out some electrical mean, so that what is the electrical mean? If I correlate the speed with voltage and I correlate the torque with current. So here you have got voltage and current both positive. Right, and here in case 2 you have got voltage is positive but the current is negative. So there comes your power electronics drive, because in a machine without any power electronics you cannot have this option like positive voltage and the current will be in the negative direction. Then only you can have forward braking operation. Okay, this is one case. Another case is that you have also the this hill, uphill and downhills, and here the thing is that here also you will have the same car, the direction of the car is the same like this, but and here also the direction of the car is in the same direction, look to be in the same direction. Right. Okay. But the thing is that you are not driving forward, rather you are driving now in the reverse direction. You are using your reverse gear, or you are trying to drive reverse like this. So let us say, begin with, this is a case number 3. In case number 3, you are trying to go uphill, but you find there is some traffic jam and you are said that okay, you can please go down like this. So you don't have any option now, because this will, if you turn off, in case 3, if you turn off the engine, this will slide down and hit the another person. You have to move it very slowly. That means you need to give a forward torque here. You need to still give a torque in the forward direction. But this would, because of the inertia, this car should fall back. This should not fall back, this should slowly move downward. So your torque is positive. In the entire case here, the speed is negative. The speed is negative, it will go down definitely, but in the case 3, you have to give a forward torque, otherwise this slowly moving down is not possible. So in case 3, you have got omega is negative and torque is positive. But this is not the case 3, torque is positive. In case 3, both are supposed to be negative here. So this will be coming under not case 3, this will be coming under case number 4. We will take this as a case 3. In case 3, in case 4, what happens? In quadrant 4, what happens? Omega is here negative, but the torque will be in the forward direction, so torque is positive. So you are still driving, giving a gear, keeping the gear in the 1 and 2. In the forward gear you are giving, and but because of the inertia, it will try to drive in the reverse direction. Slowly it will move to the downward direction. So here it is case number 4. In case number 3, what happened? You are in a downhill, but because of some traffic over on the in front of you, you need to move it upward. So when you need to move it upward, your only option is to drive it in the reverse direction, and motion is also in the reverse direction. So this is the case when you have a speed is negative and the torque is also negative. So this is one of the this is the case when you have all the 4 quadrant operation can be explained. And when I'm saying that you can use a gear and electric drive, suppose the electric drive you don't have a gear or such, you have only some power electronic devices and motor, where using the power electronic you can change the voltage and current sign or direction. So like in case number 4, your current is positive and the voltage is negative. And case number 3, voltage is negative and current is also negative. So you need to use the power electronic device and find out that how you can change the direction of the current or change the polarity of the voltage, so that in this particular 4 cases you can use this trick and you can drive the motor or you can drive the vehicle without any hindrance, and you can also go uphill and downhill slowly. Similarly, you can reverse, while in case number 3 you are reversing very slow, you can just give a reverse gear. So both current and voltage is negative, so you can move it slowly up. If you are downhill and you are going down, in that case you need to be careful, like you have to give a torque in the forward, but the motion will be in the reverse direction. So this is the 4 quadrant operation of electric drive. In books, this same thing is also explained in the hoist load. In the hoist load, let us say this is the center of the drum, where on one end you have got a load is connected. So this is, let us say, load. An empty cage, this is a cage, and other side of this drum you have got a balancing weight like this. The other side there is a balancing weight, on right hand side let us say there is a cage. So now the cage is full of people, right? So there are, suppose number of people are over here, 5 number of people are here, and now your objective is to move it up. So when you are moving it up, you are saying that omega is positive. So you are taking a lift is moving up, omega is positive. Obviously the motor torque will be, electromagnetic torque will be Tm. It will obviously moving in the direction of the speed, direction of the rotation. So your omega m and Tm will be in the same direction. And the load torque means because of the gravity there is a load torque. And load torque will obviously the opposite of the electromagnetic torque. Now this in the same case, suppose in case 2 you have a wheel, but here you have got a balancing weight, no doubt. On the other side you have got a cage, but this cage is empty. People are not there. So if people are not there, you want to move it up. The weight of the balancing weight, let us say W, is greater than the empty cage. So weight of the WB, balancing weight of the cage, and WB is greater than the weight of the cage. So that's why it will automatically roll over in the forward direction. It will automatically roll in the forward direction. But the thing is, if you just leave it, it will roll in the forward direction and this empty cage will come up and it will hit on the rooftop. So since you have to move it slowly upward, you have to give a torque in the reverse direction. Got it? So you are the motion is in the anti-clockwise direction. So omega m is in the anti-clockwise, but you are giving a electromagnetic torque instead of anti-clockwise. You are giving an electromagnetic torque in the clockwise direction, and that's why your electromagnetic torque is here in the second quadrant is negative, and your motion is in the anti-clockwise direction. That is a positive. Motion is upward, the cage is moving upward, so this is positive. The load torque here will also be in the downward direction of this. That load torque is here because of the weight. It's a coulombic friction. Where the load because of the gravity. So load torque will obviously will be in the downward direction, like this. Next is the quadrant number 4. To explain this, let us say this is a wheel drum in which we have one side is a cage. So in case number 4 and 3, the speed is negative. So we will have a imagination that here the cage is already in the up, and we will try to lower the cage. That means we will try to move the cage downward, and the other side we have got a balancing weight. So balancing weight is here. So it is very heavy. So my objective is to move it clockwise, omega m, so that this cage will go down. Now to make it go down, if I leave it also, it is not possible because this side is the lighter weight, no? So I have to drive it in the reverse direction, like this Tm. I have to drive it in the clockwise direction, Tm. So Tm will be, it is the same direction of omega m. So Tm will be positive here, right? But this case of like empty cage will not fit for the fourth quadrant. It will fit for the quadrant number 3. So let me just erase this part a little bit. For quadrant number 4, because for 1 and 4 we should take the loaded cage. So let us think that the people are over here. Now this load is going downward. Now the weight of this cage, weight of the cage is greater than the weight of this block. So it will just quickly it will fall down because it will go down quickly and it will move downward. So omega m is negative. Since this side weight is heavier, right hand side weight is heavier, we need to give a torque in the left hand side. That means positive torque we have to give. So in quadrant 4 you have got a positive torque and the speed is negative. And when we explain the quadrant 3, here we have to take that empty cage. So empty cage to be lowered down with a balancing weight on the left hand side. Now this empty cage, if I leave it also, it will not go down. It will not possible to go down because this is lighter. On the left hand side, the balancing weight is heavier than the weight of the cage. So the going down is not possible. To make it possible, I have to drive this torque in negative torque I have to give. So the speed and torque both are negative. That is the quadrant number 3. The speed and torque both are negative. Then it is possible to drive this empty cage downward. So now you have got loaded cage moving up in fourth quadrant. In the first quadrant you have motoring mode, loaded cage going downward, that is the fourth quadrant. Empty cage moving upward will be the quadrant number 2. And empty cage going downward will be the quadrant number 3. Because the empty cage, we are trying to move it downward, and also we are trying to give a reverse torque to the motor. And this dot is actually the motor shaft. It is the few of the motor shaft. Motor may be character on the other side. And by rotating it in the anti-clockwise, you are saying it is the positive speed, and rotating in the clockwise, you are saying it is a negative speed, and in this way you are trying to move it up and down. So as we write here, forward motoring and forward braking, the quadrant number 3 will be reverse motoring, and the quadrant number 4 will be reverse braking. So like that, with the help of the electrical power alternating device, we will learn that how we can achieve all these 4 quadrant operation. In short, how to achieve positive voltage and positive current, negative voltage, negative current. So this is 1, and this is negative voltage, negative current is 3. Like this, forward motoring, reverse motoring. And quadrant number 2, that is forward braking, positive voltage, negative current. And quadrant number 4, reverse braking, forward braking and reverse braking by having voltage is negative and current is positive. So like that, we can explain the 4 quadrant operation by wheel, uphill and downhill, also by a loaded and empty cage in a lift. And remember that the weight of the balancing weight is heavier than the empty cage. Okay, thank you. And in the next video, we will learn about the dynamics, that we will learn about the different loads and how the speed torque characteristics of the different load varies, and what is the suitable motor characteristics, speed torque characteristics, so that there is a match between the speed torque characteristics of the load as well as the speed torque characteristics of the motor. Thank you.